right above that. You have to understand something. It's a little fictitious because I handed you 10 starbursts in the beginning. Each of you do a calculation to see how many starbursts you won, whatever you had left after 10 rounds. Subtract 10 from that. Because remember, you had to bet $1 each time you played. Those 10 starbursts that you started with, I gave them to you today, yes? Yeah. But if you walk into a casino to play craps, you'd have to pay $10 to get those 10 chips. So in other words, if you, Andrew, how much did you have left after you were done playing? Andrew had 4. He actually won -6 because he had to take the 10. He bet 10 times, yes? 10 of those times he had to spend $1 each time, or spend a starburst. So you're down $10 at the end of the 10 rounds. Then you add whatever you have left in. So the most you could actually win is nothing. If you won, did anybody win all 10 rounds? That can happen. We're going to figure out what's the chance of it.
You're not really paying out for the bet.
Right. It's you guys. It doesn't feel like anything to you guys because I handed you 10 starbursts today. But in reality, you have to pay money to get those 10 chips. That's why I say whatever you have left after 10 rounds, subtract 10 from that. Does that make sense? So whatever you have left, all of you have a certain number left in your pile. And if you can't remember, just look up at your quiz. Whenever you won, that you got a starburst back. So the number that you won should be the number of starbursts you have left. Because if you won, you got your ante back. But that feels like you won something, doesn't it? But you actually didn't. You just broke even. You paid $1 to play, and then you won that $1 back. You didn't actually come away with anything. Does that make sense?
It's actually what it lost $2.
Exactly. Does that kind of make sense? So, what I want to do right now, let's skip the probability part that says that we'll do this together part, the probability of winning and the probability of winning experimental theoretical. We'll come back to that. What I want to do right now is let's keep track of our outcomes. Let's keep track of our outcomes on the board. So, as far as results go, the absolute best we could have done, as far as, I'm going to put this in winnings.
0.
Right, the absolute best you could have done is $0. If you won every single one of your 10 rounds. Because every time you bet a starburst, if you won, you get it back. So at the end of the day, you end up with 10 starbursts back in your pocket, like, okay, I'm going to go home now. And it's funny, I was walking down here today, and I met an old student who I had in 95 a couple of years ago. I told him what I was going to do in here. He's like, that's great, let me tell you a story. He was watching some coworkers get completely loaded and play craps together. And he knows enough not to play. And they kept heckling, why aren't you playing? Why aren't you playing? He's like, because I'm good at math. And they kept saying, oh, I'll give you $5 to play. And they ended up taking like $3 or something from one of his, he gave him $3. That was his chip in, if you will. He bought up $3 of chips. And then he played a couple rounds. And he ended up winning in the first couple rounds, and then he stopped and walked away. Now, that might sound exactly the opposite of what happened to us, except it's not. Shelly, when she was playing with me, she cleaned up in the first, I think it was 6 rounds, 5 or 6 rounds. Then she started losing at the end. But that's the idea of craps. If they keep you at the table long enough, you're going to see what happens. On average, you're going to end up losing. I mean, you have to. Mathematically, you have to. I told you the story about the movie Casino and the Japanese businessman who tried to leave. When De Niro didn't let them leave, they lost their money, even though he gave them some to start playing with. And that's not magic, as Brian said. It's mathematics. Okay, so the best you could have done was win nothing. But nobody got that, right? How many? Nobody broke even. Anybody lose just one starburst? I'm going to put dollars just because it's easier to come. Anybody lose just one? Okay, nobody's there. How about 2? Anybody lose just 2? So anybody finish up with 8? Nobody there? Shelly, you lost just 3, yeah? Or you had 4 or 3? I forget.
4.
You're at 4. Anybody lose just 3? Couple of you. 2? Good. Now, Shelly, you lost 4. Anybody lose 4? Finish with 6, basically. Finish with 6 or lose 4. That's 2 there. All right, let's look.
Plus Shelly.
Say that again?
Plus Shelly. I don't know someone over
Oh, somebody over here too? I didn't see the hand. Oh, Ryan. So you were Tori as well? Oh, so that's 3, not 2. Thank you. I missed one of those hands. 5, broke even with half. 1, 2, 3, 4. I say broke even with half. I say I lost half. 6. This is where I came in here. 1, 2, 3, 4, 5, 6, 7, 8. Did I count myself?
Yes, you started.
I did. Okay, good. How about 7? So ends with 3. 1, 2, 3. Anybody end with 2? Sorry, Sherry. Anybody end with 1?
Well,
Anybody lose every round? Okay, good. We can just leave that one off. So really, the interesting stuff happens right here. The interesting stuff happens right there. All right. So let's answer the question at the bottom. I said, how do we do as a class on average? Let's calculate the average winnings based on this chart. What's our average winning? Now, Micah.
Would you lose everything as part of your average winnings?
Well, we don't have to as our class because it didn't happen.
Right.
So,
but 0, 1, and 2 didn't happen.
I didn't buy, exactly. I wrote those down because I didn't know they were going to happen until I got to 2 and 3 and 4 and 5. So I put the box around the interesting stuff for us, and you'll see why mathematically we can ignore 0, 1, and 2.
Okay.
It'll make sense momentarily. How do we take the average of this? We've done it. It hasn't been. It's been at least 3 or 4 weeks since we did it. Andrew, do you remember?
you multiply by and then add.
Right. This becomes a GPA calculation. This is called a weighted average. Now, it's very tempting to go -3 plus -4 plus -5 plus -6 plus -7 plus -8 plus, and then divide by 7. But I say, no, that's not right, because we had more, for example, -6s than -3s. So you have to keep track of all of that. But that's what Andrew just told us. So this is how you do your GPA, too. I'm going to swing this over. I'm going to swing it over here, actually. And we're going to do it out. This is what quite a bit of Math 243 does, is analyze this kind of stuff. So what I'm going to do, our average winnings. Average winnings. We're going to do a weighted average. Now, essentially, we are going to add everything up and divide by how many there are. We are. But we're going to do it more slickly. Because in order to add everything up, we have to add 2 -3s, 3 -4s, 4 -5s, 8 -6s. I don't want to do that. I don't think you do either. So rather than adding 8 -6s, we'll do 8 times -6, which will give us the exact same result. That's why we did the multiplication anyway, to not have to add all the time. So on the top, we're going to have 2 -3s plus 3 -4s plus 4 -5s plus 8 -6s. I'll have to come down here. Plus 3 -7s plus 2 -8s. And Micah, hopefully you now see, it was a great question you asked earlier, plus 1 -9. Why we don't have to include the 0s, 1s, 2s, and -10s. Multiplied by 0, they cancel out anyway. And then, that's the numerator. That's how much money we won as a class in total.
Is that 21?
Is that what?
Is that 21?
Yeah, it's 3 times.
Oh God! I was doing the math in my head. 3 times 7 is 21. Thank you, Nick.
Yeah.
3 times 7. Sorry. ADD brain. A bunch of different things firing at once. So, that's how much money we all won as a class. But in order to do the average, we have to divide that by how many of us played, which would be 2 plus 3 plus 4 plus 8 plus 3 plus 2 plus 1. That calculation will give us our average winnings overall, per 10 games. And then if you want to go even further, you can divide that by 10 and figure out, because you each played 10 games, we can divide that by 10. So this is per 10 rounds, and it sounds like Andrew's already got it for us. You already crunched the math for us, Andrew?
I think it's 5.7.
-5.7, and we got a second on that? Thank you guys, appreciate it, because making me do this math would be a disaster right now. So if you crunch all this out, it ends up being -$5.7 on average. Now that, hopefully, I want you to think about why that makes sense based on the data in that chart over there. Nick, you asked me a very good question earlier about 243. Some of you are joining us for the journey on 243 at 244. Some of you. Very often, I'll look at a data set like that, and I'll ask 243, where's the average? And I don't want an exact calculation like this, although I do want an exact calculation here, because we're pretending we're Vegas casino officials and keeping track of wins and losses to make sure nothing shady's going on.
said 5.75, negative 5.75.
That's what I'm here. 5.75 is what you guys are getting? 5.7?
I got 5.7.
5.7. We'll go 5.7. It's fine. But I'll ask my 243 kids, where's the average based on that data? Where's the average based on this data? And I won't ask them. I won't ask them for an exact. I'll say, there's the data. Where's the average? Now, clear. Mike, go ahead.
Just one quick question.
Oh, go ahead. Yeah.
On this average, we're doing it, average would be per
10 games.
per 10 games. Okay.
It's per person per 10 rounds.
Okay.
We'll correct that for the 10 in a second. We'll divide that by 10 and get it per
Does that
game.
mean we basically did 20 rounds?
You each combined did 20, yes, 10 and 10. Yeah. So technically, whatever the denominator sums to, which would be 5, 17, 23, that's 230 games. Because you all played. That 23 is 23 people that played the game today. Times 10 for 230 rounds. So we're going to have to divide by whatever that is by 10 to figure out per round how much we won. Quote unquote won. We'll come back to that, yes? Okay, so here's the deal. Or lost, exactly. Say that again?
You played too, so there's 24 people in the room.
Oh, there are. Oh, there right.
Someone's over.
I did count myself.
Yeah.
But that doesn't mean well, it's okay, guy. Don't sweat it. It's not the end of the world. But you're right. I must have just counted wrong when I was going to scope it up. You're right.
There was even numbers.
Or I just counted wrong. Always point the blame here. It's usually here when it comes to counting. But could you pull the average from this? Could you pull the average value of roughly 5.7 from this?
Yeah.
I mean, the most common was -6, right? The most common was -6. And there's more data below -6 than above, but not a whole lot more. So 243 would say, it's between -5 and -6. And they're right. That's exactly where it is. It's -5.7. So that's the kind of stuff we'll do in 243. We'll look at a graph and go like, okay, there's the high. The average is probably somewhere close to that. And that's the idea of reading the newspaper too. If you could see a graph or two graphs next to each other, being able to pull where the average is off of a graph. You can do that. We can get more precision, of course, doing what Andrew and Micah did. But you can get a ballpark estimate just looking at it that way. Fair enough? Good. Very good question. All right, so we have an average. So, on average, after you guys played 10 rounds of craps each, you averaged a loss of 5.7 starbursts per 10 rounds, which means you averaged a loss of 57 cents per each round. Now make sure that makes sense. This was per 10 rounds, so dividing it by 10 gives us the average per 1 round. Why is Vegas like this?
Because you're losing more than half the time.
Because they gain that 57 cents every time you lose it, correct? Every time you lose that 57 cents playing a pass line bet, they gain it. Negative to you is positive to them. I was telling Shelly as we were playing the game up here, on your out-of-class exam, if you haven't seen it yet, part of it is exponential modeling, which just deals with my old singer Andy drinking 3 Red Bulls before a show, which is fun to analyze that. But the other part of it is the don't pass bet. So there's another way you can bet. Actually, there's a bazillion ways you can bet in craps. Craps is amazingly complex. This is the simplest one to, as crazy as it is, it's the most common bet, and you can see why. It's so easy to get caught up in those point rounds. 7, or no, actually not 7, 6, 8, 10, whatever you're calling for. But there's other ways to bet. For example, you can bet against the shooter. The shooter's trying to win. The shooter's trying to do pass line like you're doing right now. There's one called a don't pass bet, which means if the shooter loses, you win. Now that might not sound like it makes a whole lot of sense, because the shooter is going to lose more than half the time, which means if you're betting against the shooter, they're going to win more than half the time. But Vegas controls that by changing the rules slightly, and part of your out of class for next week is to figure out how they make the adjustment in the payoff to control for that. Because they have to keep their house edge. They have to keep their house edge, and the only way they can keep their house edge is if you're losing money on average. And that's why I want to come back to the previous questions on what are the chances of winning? What are the chances of winning? Fair enough?
Yeah.
Okay, any questions so far? Does this make sense? So I think we just answered,
Number 5.
yes, we answered 4 and 5, yes? So now what I want to do is, I want to go back and I want to answer 2 and 3, which is what is the chance of winning and losing? Because that's what I want to calculate. because it's one of the most interesting calculations in all of Vegas mathematics. You know, because Vegas mathematics is rich, and some of it we can't analyze. Poker, you'll never hear me analyze poker. Why? Say that again. What variables in particular, Hassan? Yes, 100% correct. Well, that makes it, in my opinion, impossible. Thank you, Nick. Nick said how many people are playing. That, in my opinion, makes it impossible to analyze because you can't control what they have, what their cards are. You can card count to some degree, to kind of and that's one reason. If you card count, they'll kick you out of it. See, it's not illegal. They'll kick you out because you're raising your odds, but you don't know exactly what they have.
Is bluffing another reason?
That's another reason. I don't know how to measure bluffing because you're playing against. Oh, it's not a pure game of chance. It's chance when you get your cards dealt to you. Yes?
Yes.
That's the chance part. Shuffle the deck, deal them out.
And then skill.
Then it becomes skill. Any game that's a game of skill, I resist trying to measure quantitatively because you can't measure things like bluffing and little body movements quantitatively. You can observe them. People wear sunglasses to hide their eyes and things like that, or they'll make certain motions with it. I can't measure that. I can measure things like craps because the dice are falling. All you're doing is you're betting on an outcome. And the outcome's purely random, but blackjack, knowing when to stop, right? I can't measure that. I can't measure how well you know when to stop. I can't measure how well you bluff. So you'll never hear me talk, and it's interesting, if you look online at the chance of certain card hands, like royal flushes and things like that, whenever you see a probability given to you, it'll always say, what is the chance of being dealt a royal flush? In other words, what's the chance of me going boom, 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 boom to nick 5 cards? How realistic is that in a poker game? It's not, because there's at least 2 people playing. And you won't get all 5 cards off the top. You'll get 1 card and it'll go around. Then the next card will go around. And you see the problem. The next card you get is dependent on all the cards that went out in front of you, hence card counting. But it's too hard to measure. It's hard enough to do, let alone measure. So you'll never hear me analyze poker or blackjack or anything like that. I like things like roulette and craps. Andrew?
You can't even do card counting in poker because you can't see what the other guys have.
But you can deduce by what they've shown you what they might have.
Oh, if you're playing.
Correct. If you play a certain kind of poker, exactly. Exactly. You're thinking of, I think you're thinking of Texas Hold'em.
Yeah.
But it's different. It's different with different wild cards out or things like that. Yeah, I see what you're getting at. In 243, coming back to that again, I have you guys analyze Texas Hold'em. If you're sitting 3 to the left of the dealer after the river, what's the chance of drawing a flush? And that's impossible to do theoretically. But with Excel, all you do is you set up 10,000 trials and count. All you do is you count. You let Excel count, which is what we'll do when you guys get back from your break. We're going to count the chance that you guys won at this game. Yeah? Let's do that. Let's take 5 though, because you're getting that glazed look and you're under sugared. So.
I want to eat my layers.
Well,